Make this Christmas memorable with Goat Guns. Get the coolest miniature gun models for your collection. From historical classics to modern weapons, we have something for every firearm and hobby enthusiast. Surprise your loved ones with the gift of Goat Guns, the perfect blend of quality and detail. Shop now and spread the joy at goatguns.com.
With Kroger brand products from Bakers, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Bakers, fresh for everyone.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on Space Nuts, the astronomy podcast. I'm your host, Andrew Dunkley, and with me, as always, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew.
How are you,
Good to
sir?
hear your voice. Yeah, I'm fine, thanks.
You're at home today, and Mandu's prowling around. So
Somewhere, yeah.
those who have been following Mandu on Twitter may get an impromptu interaction. We don't know yet, but yes, we'll see how he goes.
He's crashed out on the carpet at the moment, but looking... I'm sure he can hear his name being mentioned. He's looking very suspiciously at me.
Yes, they do that.
What's he up to?
Yes. Well,
Shall I scratch his eyes? No.
Let's just see how we go. Today, we've got a lot to talk about. Of course, the Indian moon landing ended in failure, which has been very, very sad. I think hopes were high and things were looking good right to the last second, and then something went horribly wrong. So we'll look at that. New research regarding the lakes on Titan. And we're going to revisit the dinosaur asteroid, where they've been sort of getting down and dirty in the Gulf of Mexico to try and learn as much as they can. And they've found something, which we'll talk about. And we've got questions about the expanding universe and revisiting the short haul travel idea for astronauts and rotational gravity. So let's get into those a little later on, Fred. But this moon shot by the Indian Space Research Organisation has ended in failure. It looked so good for so long, and then something dreadfully wrong happened. They're still trying to piece it together, from what I can tell.
Maybe literally. That's
Maybe
right.
Literally.
So the good news part of this story is that the orbiter, Chandrayaan-2 itself, is in perfect working order. It's in orbit around the moon, and I think it's got a year's worth of data or a year's worth of science to carry out before the mission ends. So we've got a really positive side to the story as well. However, the Vikram lander, which was dropped or propelled down to the moon on Saturday, the 7th of September, apparently functioned perfectly until it was within about 2 kilometers of the surface. And then contact was lost. So that's, not a good sign.
No, definitely not.
Even though for a moon landing, you've got to have the thing essentially under autonomous control, because you can't, beam the signal back to Earth and say, tweak it here, because there's that 2.6 second time delay between signals going from the moon to the Earth and then back again. So it's and that's even if you instantaneously respond. So it may well have survived, but the present news is that the lander has been located on the surface. by the orbiter using infrared cameras, actually, and they found something that is thermally warmer than the background lunar surface, and that's how it was identified. What is not known, at least to the best of my knowledge, and this is really as of yesterday, what is not known is whether the lander is in one piece or many pieces.
I've heard some conflicting stories about what might have happened. They're talking potential engine failure. Another theory is that the descent was good, but they miscalculated the moon's gravity, which means it hit the ground harder than it should have. The observations from the orbital craft seem to suggest it is upright but on a slant. But bottom line is they still don't know exactly what went wrong.
Yeah, that's the news I've got.
Most likely engine failure, but they can't confirm that. And I suppose they're trying to communicate with it and hope that they can get some activity out of it. But at the moment,
I mean, that's right. It's you know, given that you've got an orbiter that is under the same control, maybe it would be possible to bring some information back. So at the moment, that is, you know, where the situation is. But, well, maybe fingers crossed for Vikram, the lander, which maybe it did land and maybe bits of it are intact.
Yeah, it doesn't look good for the rover side of the
no, that's right.
situation.
Which is it within which is within the lander. Either way, you know, it's still a monumental achievement for the Indian Space Agency, and all credit to them for getting this far. And I'm sure that they will succeed in the long run.
Just don't look at it as absolute failure. Get up, dust yourself off, and go again. That's the best way. And find a few.
That could be a song, you know, Andrew.
Find a few gazillion rupee while you're at it. Which probably will help.
Actually, the Indian Space Agency runs on a very, very economic budget. It's a very tight budget. Interesting.
Maybe that was part of the problem.
Well, there you go.
Maybe. I don't know. Fingers crossed that they'll salvage something out of it. I do hope that maybe it'll just suddenly come to life. Who knows? We'll wait and see. Now, let's move along to from our moon to another moon, and that of Titan, which the Cassini mission has been sort of focused on, and they've made a bit of a discovery about the lakes on Titan. This is fascinating.
I think it is too. It's work done by an international team of scientists, and in fact, they're led by an Italian planetary scientist, Giuseppe Mitri. He and his team have looked afresh at some of the information that has come back from Cassini, actually during its final flyby of Titan. I can't remember how many flybys of Titan it had, but it's certainly, I think it was 20 or 30, something like that. It might be more. But this was, you know, really right at the end of the Cassini mission, which ended almost exactly 2 years ago. So what has happened is that these scientists have used the radar imaging data that has come back from Cassini. Remember, Titan's got this thick atmosphere, or pretty opaque atmosphere, which is laced with hydrocarbon smog, and that prevents visibility directly down to the surface, except under rather special conditions. You can do it with infrared at certain times of the Saturnian year, but radar is the way to do it. So the radar images that have been analysed show a feature of the smaller lakes, which, like all the seas and lakes of Titan, are predominantly around the North Polar region of the moon. So the smaller lakes seem to have these rims around them that stand much higher than the lake level itself, and higher than the surrounding landscape. So it's almost like a wall around these lakes, up to, well, you know, tens of meters high, maybe hundreds of feet high. They're not little they're not little things. They're really significant structures.
Which would be easily explained if it was a gorge or something, but it's a lake.
Yes, that's right. It's a lake, and the key thing is that the larger seas don't show these. The larger seas, which are bigger than the Great Lakes of America, they're bigger than the biggest freshwater lakes on Earth. They don't have these features. They do have very well-defined edges. Very well-defined shorelines, if I can put it that way. But they don't have these rims around them, which only the smaller ones do. And so that's caused a lot of head scratching as to why this should be the case. And that's just been published, actually, within the last few days, that essentially the feeling is that the bigger seas formed by methane pooling in the icy surface of Titan. Remember, the surface is not rock, it's solid ice.
Yeah.
And so if you get, undulations in that, the methane pools in it. And, excuse me, under certain circumstances, the methane can actually eat into the ice. So what you get is a situation where you get an ever-growing sea or lake, and around the edge of it, there's just a standard kind of boundary, just a normal shoreline. But the speculation about these ones with the rims, the smaller ones, is that they're caused by explosions, not kind of chemical detonations, but physical explosions of nitrogen, which has been liquid, suddenly turning into basically a gas underneath the surface of the ice.
Okay.
Blowing off the surface.
I was thinking the opposite. I was thinking some kind of impact, but it's come from underneath. It's blown out.
That's the feeling. Yes. There's a excuse me. There's a basically a story to tell that the atmosphere of Titan is a really good greenhouse gas atmosphere and keeps Titan warmer than it otherwise would be, even though its surface temperature is still, I think it's about minus 180, minus 190 Celsius. It's very cold. But if you've got a climate change, a slow climate change on Titan, excuse me again, Andrew, I've got a Titan in my throat. That's all right.
Freddo frog in your throat.
Freddo Froggy, that's right. So there's been periods where it's been slightly warmer, periods where it's been slightly cooler. And the thinking is when Titan is cooler, you've got a nitrogen cycle in the atmosphere. So you get nitrogen rain and nitrogen evaporation. And the thinking is that the nitrogen has collected in pools sort of beneath the surface, underneath the icy surface of Titan, almost like a kind of water table, but with nitrogen rather than water. And then the suggestion is that if you've got these sort of masses of liquid nitrogen in the crust of Titan, if you get some warming, then that liquid nitrogen vaporizes, expands pretty quickly, and blows out a crater which has rims. And that's a very interesting and new analysis of what we see. There's actually a lovely comment from the Cassini project scientist herself, Linda Spilker of the Jet Propulsion Laboratory, who, by the way, we are expecting to come to Australia later in the year to do some lectures, which will be brilliant. But what Linda says is this is a completely different explanation for the steep rims around those small lakes, which has been a tremendous puzzle. As scientists continue to mine the treasure trove of Cassini data, we'll keep putting more and more pieces of the puzzle together. Over the next decades, we will come to understand the Saturn system better and better. So, it's still a work in progress. It's great that 2 years after the spacecraft vanished, these new results are still coming out. And yeah, it would. It's great to see.
Yeah, it's sort of like medical studies on Earth. You can get studies from studies, and you can go back and look at 10 or 15 studies on one particular topic, collate the data, and go, hang on a minute, and learn something new. So that's very exciting. And you know what? It sounds so logical. It sounds like a pretty simple answer to an issue that has had them scratching their heads. So they're probably on the money with this one. So
Exactly.
it'd be good to get that confirmed. But fabulous. All right, you're listening to Space Nuts. Andrew Dunkley here with Fred Watson and Mandu. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments, and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and skiing with a go.
Space Nuts.
Now, Fred, we revisit an old friend, the Chicxulub impact crater in the Gulf of Mexico, where an asteroid struck the Earth and helped with the demise of the dinosaurs. Now, you and I have spoken about this in the past because they've been visiting the site, and in particular, drilling into the underlayers of the impact point to see what they could see. And we've learned a bit. We learned that this asteroid was probably not the absolute reason for the extinction of the dinosaurs, but certainly did make a big impact, boom, boom, on their ultimate destruction. But with or without it, they probably would have disappeared anyway. It certainly changed the atmosphere dramatically for a long time on Earth, caused major tidal waves around the planet. It would have been a horrible place to be at that exact moment. But in the course of this research that they've been doing, they've been finding some fascinating information, and now they've released a little bit more about what's down there at the impact point.
Indeed, and this research comes from Sean Gulick, who's at the University of Texas in Austin, and it builds on. In fact, I think what it's actually analysing is something that we spoke about probably a couple of years ago, and that was the core drillings, core sampling that was being done there. And you might remember that there was a drilling vessel which had the lovely name of Myrtle.
That's
and
right.
Myrtle floated in the Gulf of Mexico and drilled down into essentially the region which is known as the peak ring of a crater. So craters, by large impacts, have an outer wall, but they also have an inner ring as well, excuse me, which is sometimes known as the peak ring. Now, the peak ring's well and truly worn away, as is the outer wall actually of the Chicxulub crater. But the sort of the peak ring is still obvious from, if you do geomagnetic surveys and things of that sort, you can see the effect of you can see the structures underneath the surface. So they chose a site to drill in, and it was actually the International Ocean Discovery Program that that did the drilling back in 2016. In fact, it's a bit longer than I remember it. It's 3 years ago rather than 2.
Wow, that's
and so, yeah, that's right. So they are looking at that basically drilled into that peak ring region. So the structures that have been revealed really tell a quite cogent and quite complex story. And remember that all the action took place within the first minutes or hours of the impact itself. I on my computer have a simulation, which I think it may even have come from the University of Texas. I can't remember where it comes from, but it's a simulation showing the immediate effect on the geography of the impact, and the Earth's surface behaves more like a liquid. You get this kind of splash, which is over a matter of 5 minutes or so. You get mountain ranges higher than the Himalayas being built and then falling away very, very dramatically. Of course, it's being made molten. So what was the series of events that have been revealed by the analysis of these core samples? And basically, it was that the impactor landed in the ocean, and the blast itself just blew the water away. And so what there would have been was this zone of molten rock, which is effectively liquid, which is now basically solidified. It's lava. But what's really interesting is that after that, shortly afterwards, the water came back again and basically hit the molten rock. And
with Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
had exploded into this, high pressure steam. And so you've got shattered rock, which has been caused by that, which also shows up in the core samples. And then on top of that, there's something like 100 meters, nearly 100 meters of sediments which are like gravel. And they're graded. So there's bigger lumps at the bottom and smaller lumps at the top. And it apparently, is once again symptomatic of water being rushed away and then coming back full of rock from the blast that then settled to make this sort of gravel stuff. Really interesting, on top of that, there's a layer of material that might have been the result of the tsunami that the impact created, because the outward stream of water that would have come from the impact actually would bounce off the higher mountain ranges, and apparently the nearest mountains are in Mexico, or what is now Mexico, about 800 kilometers away. So they bounce off that and then come back, and you get another layer of sediment on top of the stuff that's already there. So it's analysis of all this that allows this really interesting story to be told of what the scenario is immediately after the impact. Yes,
hello, Mandu.
Yeah, he's agreeing with that, which is good. It's just I'm glad to hear it. But the thing that makes it really interesting to me, Andrew, is the sort of analysis of the material of the rocks, because the stuff that's been found in the crater, and this is all, the stuff that's been washed back by the returning tsunami wave, it's actually low in sulfur. And that contrasts with what the general sulfur level in the area is. In other words, there's relatively high sulfur in the rocks in the zone where the impact happened, but the stuff that's left after the impact is low in sulfur. And the suggestion is that was caused by the sulfur vaporizing by the heat of the impact. Mixed with water, you've got basically this haze of what they're called sulfate aerosols. And that is maybe the smoking gun for the dinosaurs, because that haze would have prevented sunlight reaching the surface as it normally would. And the suggestion by these researchers is that it might have dropped the temperature by maybe 25 degrees Celsius, something like that.
That's a big drop.
It's huge, that's right. So you've suddenly got a world that's well cold, and actually much of it below freezing. The average global temperature is about 15 degrees Celsius. And the suggestion is that this might have lasted for 20 years or so, something like that.
Yeah, and the power of the impact, they say, was what, 300 nuclear bombs or something?
No, many, many more.
Okay.
This is global. It was a 15-kilometer diameter object. It's got global effect. It's the yardstick that I remember from years ago is that an impact by a 100-meter object would have the same devastation effect as a 100 megaton nuclear bomb. And a 100 megaton bomb has never been tested in the Earth's atmosphere. So, and that's just 100-meter objects. This is 15 kilometers in diameter. So you're talking about global extinction, which of course happened. I might just mention, if I may, just for completeness here, there is a very nice complete account of this research, which has come from Richard Lovett, who is a science writer. He writes for Cosmos magazine, and so if you check that out, you'll find his article there. The rocks below a famous crater. It's a very detailed account.
Actually, I think I've just done a quick search, and I think the impact would have been, they say, the equivalent of 2 million 50 megaton TNT bombs.
That sounds about right. That sounds about.
That would literally blow your mind.
And the planet.
Yeah. Well, I did actually watch that video while you were talking, or a video of the reconstruction of those events, and they showed sort of impact, and then a couple of weeks later, and then a couple of months later, and then
I haven't seen that one.
That's a different one. I think that was done through the University of Chicago, but it is quite a telling series of events, and even years afterwards, the effects were still pretty prominent on Earth, and now we're 65 million years later or something, and we've got to wait another 35 million years before we get hit again, which is good on average.
On average, that's right.
That's handy.
But these things don't wait for averages, though.
No, they do not. That's the problem with averages.
The great thing about, Andrew, by today's standards, a 15-kilometer asteroid will be very easily visible with the telescopes that we now have at our disposal.
Unlike one that hit us the other day that they didn't see till the last second, and then when they did, they went, "Oh, it's going to miss," but no, bang into the planet like a baseball into a glove. But
this was a few meters across.
Yeah,
or something,
it was
wasn't it?
Too small to do anything. It had vaporized. But I guess you can't see everything. But as long as we see the nasty ones, that's all that matters.
That's right.
All right. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Now, before we get into today's questions, a shout out again to our patrons who are supporting us on Patreon. Thank you so much for your support. We really do appreciate it. And if you would like to support Space Nuts through Patreon, and just maybe spend a couple of dollars a month to support the program, you can do that too at patreon.com/spacenuts. That's patreon.com/spacenuts. Check it out. It's a wonderful thing to have the audience come to us and say, we'd like to support you. How do we do it? That's why we set it up, and people the people came and supported us, which is fantastic, and we really appreciate it. And if you would like to meet fellow Space Nuts supporters, you can do that on the Space Nuts Facebook group. All you have to do is put Facebook Space Nuts group in your Facebook search engine, and you will find the group and request membership, and we'll sort it all out for you. But those numbers are growing very, very fast indeed on both platforms. So fabulous stuff. And thanks for your continuing support of the Space Nuts podcast. We're into episode 170, Fred, by the way, which is just I can't believe we've done that many episodes. It seems like only yesterday we got this thing started.
Yeah, that's right.
But it's fabulous.
Oh, 170.
People are enjoying it, and that's the main thing. And the number of people that actually email us and say, "Wow, look, I've really learned a lot," and that is fabulous too. Now to some questions from people who want to learn more. This one from Alan Weston. Hi, Alan. Thank you for your question. So my understanding of the expanding universe is that it's not so much the galaxies moving away from each other, more that the fabric of space is expanding, putting more space between the galaxies. So I have two things I'm wondering about. I assume this means all space is expanding, the space between you and me, the space between my house and the next door neighbour. Sometimes that can't happen fast enough. The space between an atom's nucleus and its electrons. And if space is expanding and space-time is the one thing, is time expanding also? And is this why the expansion is speeding up? Or is it the opposite? And when we look millions of light years into the universe, we are seeing a time when time was faster. I think my brain just exploded. Alan Weston. Yeah, I think so. Well, actually, previous segment, our brains exploded. But anyway, we'll see if we can tackle that one, Fred.
Yeah, so part one, yes, Alan's absolutely right that it's space itself that's expanding. It's only when you look at the universe on very large scales that you actually see it. So while technically the space between his house and the one next door is expanding, you would have to wait a very, very long time indeed before you noticed even 1 inch or a centimetre of expansion. I should work out the time that it would take for you to move an inch, but I haven't time to do that at the moment. It depends on something called the Hubble constant. That's the number that dictates how fast it's expanding, and it basically is a velocity, and it's related to the distance, how far away you look. So yes, space is expanding. Now, it's really interesting what Alan says, that is time expanding also, and in our local environment, the answer is no, because we're in the same reference frame as the space, if I can put it that way. So you don't see any change in time. But the second part of the question, and I'll read it again, is the opposite. When we look millions, is it the opposite? When we look millions of light years into the universe, we're seeing a time when time was faster. And I think that's essentially true, although actually what we're seeing is a slowdown of time, because our vantage point here, if you think, okay, we're looking back into the universe to a time when the universe was much denser than it is now, and that means matter was concentrated more tightly. So you're looking back to a time when gravitational time dilation takes place and time passes more slowly to our eyes as we see it from our vantage point. And I think that is probably true to the extent that when we look at when our physics applies to the early universe, what we find is things happening over incredibly small timescales. So this process known as inflation, where the universe expanded from the size of a hair to the size of a galaxy in something like 10 to the minus 33 of a second. I can't remember the exact number. It's about that. It's probably partly that sort of effect that you're seeing. I have to say, I haven't really studied this in detail, but it is something I've thought about in the past, that the gravitational time dilation effect on our view of the early universe. I should go and talk to some of my cosmology pundits about that and get a more definitive answer. But I think Alan's thinking is certainly interesting and possibly on the right lines. However, where it does break down, and this is Alan thinking I'm talking about, is that the accelerated expansion needs to have a different mechanism. It's not just an illusion of gravitational time dilation. It's a real effect in the expanding universe. The accelerated expansion, which we put down to something called dark energy.
Aha. Okay. Thank you, Alan. You're a smarty pants. Very, very good question, though. It's just hard to imagine that the space between you and me or the neighbour's house is actually an ongoing thing. But as you say, it's going to take a very long time for a small amount of space to be created. So,
that's correct. But just to clarify that a bit, the force that holds the Earth together is as Mandu says, is quite well able to overcome that. The forces between atoms are much more capable of holding things together than the expansion of the universe is going to be to pull them apart. Yeah. And likewise, gravity holding galaxies together. The gravity is much more efficient as a mechanism for holding things together than the expansion of the universe is for pulling it apart, just because of the small amount that's involved.
Indeed. All right. Thanks, Alan. Let's move on. Hi, Andrew and Fred. Big fan of the show here. Love the topics you cover and the way you deliver them, so please don't stop. Damn it, we were just planning that. Never mind. My question is a follow-up to Devon's daily space travel question in episode 168. Fred mentioned there is an adjustment period that the human body goes through when arriving in space, similar to jet lag. How do you think this translates to rotational gravity on a space station? Astronauts would surely switch between gravity and microgravity much quicker than what has been observed in the past. So do you think the adjustment period would stay the same or reduce as the astronauts get used to it? Also, he's got a second question regarding the Alcubierre metric. The original paper details requirements exceeding the mass of the entire observable universe for it to function. Fred has mentioned this in 2 episodes, so I'm not sure if he's familiar with the work done by Harold White at NASA that seems to theoretically reduce the power requirements from universe mass to the mass of the Voyager spacecraft. This sort of stuff is well beyond my scope of understanding. I'm talking about myself now. No, but I'd love to hear you discuss it on the podcast. And thanks, guys, and say hi to Mandu, Richard Fox. Thanks, Richard. Mandu said hello to you, I believe. So he's got 2 questions. The first one in regard to the idea that Devon came up with about daily commutes into space and back, and how that might be very, very difficult. But if we had rotational gravity, artificial gravity, I suppose, could that be a solution?
Yeah, maybe so. That you could then do the daily commutes if you commuted to a space station, a bit like the one in 2001: A Space Odyssey, that was in Earth orbit but rotating and had all kinds of paying passengers on board. If you could do that, I think Richard's right that you essentially take away one of the things that does contribute to deterioration of health in space. There are many others as well, but many of them are dictated by the fact that you're in free fall, the absence of weight. It's not an absence of gravity; it's an absence of weight. So I think that's an interesting suggestion. And once again, I would like to talk to space medics, and I do know a couple. About that. So maybe what I should do, the trouble is that the space medics I know are all based in the USA, maybe dropping a line to somebody with that question, and it might elicit an answer which we could then relay to our Space Nuts listeners sometime down the track. So I will check up on that. And the second part of the question, Richard is right that I'm not familiar with Harold White's work. This is all about warp drives, I think.
Yes, that's right.
The fact that the original work suggested you needed the mass of the entire universe to make it work. But new work, and I'm always open to reading new work, and Richard's kindly sent me a reference to it, might change that. So I will have a look at that. And once again, maybe that's homework for me, and down the track, we'll talk about this again.
Okay, beauty. Thanks, Richard, for your question. In regard to rotational gravity, it's not something yet we've perfected in terms of creating artificial gravity in space, and it's something that's obviously going to be seriously looked at, particularly if you're talking long-haul space travel. But I do note that there's an organisation called the Gateway Foundation, which is planning to put a hotel in space. They reckon it'll be operational by 2025 and will have artificial gravity. So, I mean, that sounds like a pretty ambitious goal. But it is. I've looked at their website. They have plans to create a hotel for 400 guests. It'll have restaurants, bars, cinemas, the whole bit, in orbit by 2025 with artificial gravity. I mean, I think they're probably pushing the envelope a bit. But look, I hope they pull it off.
Maybe 2035.
Maybe, but still, you never know.
You never know. And good luck to them. I think. Space entrepreneurs, they are forward-thinking people with some great ideas, and not all of them will come to fruition, but no doubt some of them will.
Yes, indeed.
I mean, who would have ever thought that you could land booster rockets back on their tails and reuse them?
Well, who would have thought in the early years of the space race that we'd be talking space tourism? Yeah. And I think orbital hotels are probably not that big a stretch.
In fact, just to I don't know whether he's got anything to do with the Gateway Foundation, but the Bigelow organization, which is a chain of hotels in the United States, they've had orbiting modules up in space to test some of their ideas for actually, I think, 16 years. I think it was 2003 the first one was launched. And these are inflatable modules, Andrew. They're inflatable.
Oh, that's right. I remember that.
And the Bigelow concern is dead keen on turning them into hotels. They've actually got an inflatable module on the International Space Station, which is being trialled, and I think is forming useful extra space on the space station there.
Yes, that's right. We have talked about that before. This one would be called the Von Braun Space Station.
There you go.
Anyway, we'll keep an eye on that one because there might be something to talk about in the not-too-distant future. Fred, as always, and to you, Mandu, as well, thank you for your company today. We really appreciate it.
It's a great pleasure. Mandu's walked off in disgust. He's gone out through the cat door. He clearly felt his comments were not being well received and has taken his comments elsewhere.
What a catastrophe. Oh dear. I had to use that one. Thanks, Fred. We'll catch you again real soon.
Sounds great. Thanks, Andrew.
Astronomer at Large, Professor Fred Watson, joining us every week here on Space Nuts. And thank you for joining us as well. We appreciate your support of the podcast and hope to talk to you again very soon. I'm sure we will. And don't forget to chase up your fellow Space Nuts on our Facebook podcast group. And we'll see you next time on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.
With Kroger brand products from Bakers, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Bakers, fresh for everyone. With Kroger brand products from Bakers, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.